Today I'll be demonstrating how to build a basic three-piece anchor using a cordelette. The cordelette I have here is made from 7mm accessory cord. It's tied off with a double fisherman's knot, ensuring that there's adequate tail on either side of my knot, usually about 3 to 4 inches. And average length for a cordelette to build anchors with is going to be around 20 feet. It's a really versatile length that's going to allow you to build a multitude of anchors with that same cordelette. Now, a three-piece anchor is a common type of anchor that you're going to build when you have to place traditional cams, traditional protection at the top of a route, and you're most likely going to encounter this while trad climbing or multi-pitch climbing. So it is important to note, it's a good idea to have an idea of what type of anchor situation you're going to encounter at the top of the climb before you leave the ground. That way you know you're bringing the right tools and the right skill set to build an appropriate anchor when you get to the top of the climb. Now, this video we're not going to cover how to place traditional protection such as cams and nuts, stoppers, etc. It's always a good idea to practice any new climbing skill safely on the ground before you go out and try it on real rock. For today's video, I've just placed 3 quick draws in the jamb of my door, but you can be creative with practicing anchors at home. You can use a door, you could use a chair, or the legs of your desk, a coffee table, etc. So here we're imagining that each of these quick draws is a piece of protection that's been placed securely in the rock. And what we want to do is we want to start by taking our cordelette. We want to locate that double fisherman's knot in the cordelette. And to simplify things later, I want to make sure that this knot stays out of the way. I don't want this coming anywhere near my master point. So we're going to start near the double fisherman's knot. What I'm going to do is I'm going to take my cordelette, I'm going to clip it into the high point or the highest piece in my anchor near that double fisherman's knot. And what I'm going to do is, to keep this up here and out of the way, is simply going to tie clove hitch. And that clove hitch is just going to ensure that this knot stays right here. Another consideration when tying in this first point is, 1, keeping this knot up and out of the way, but 2, I've placed it in such a way that the knot is in front. So the knot is not in the back up against the rock. What I don't want is this knot sliding against the rock and braiding that knot could weaken it. So I've tied it in a way that once my anchor is formed, this knot is going to be out here in space. Nothing's going to bother it. Then what I'm going to do is I'm going to take a single strand of the cordelette. We're going to go ahead and clip that into the remaining pieces of our anchor. And next what I want to do is I want to gather that strand, pull down in between those pieces. So between these 2 pieces I'm pulling, and between these 2 pieces I'm pulling. And we want to just continue to pull down. Ultimately what we're wanting is to get these 2 loops and our unclipped loop of cordelette all brought together as best we can. And I want to pull until all the strands are nice and tight and equally under tension. So next what we need to do is we need to determine where the direction of pull is coming from. And what I mean is, when our climber is on the route, which direction relative to our anchor is that climber going to be approaching? Because we want to know where that force is going to be pulling. This is what we call a pre-equalized anchor. So we want to equalize in that direction. So we need to be able to anticipate that direction based on the route and where that climber is coming from. So when I say equalized, what I mean is that each of these strands, which we refer to as the legs of our anchor, so each of these legs is under an equal amount of tension. I don't want any of these to be slack. I want all of these to be nice and taut as we pull and load this master point. And what that does is whatever force or load is pulling on our master point, that's going to mean that that total force is being divided equally to 3 different pieces, and that's going to help with the strength of our anchor. So if the climber is approaching the top of the climb from way over here to the left, I would want to pull and equalize my anchor in that direction. For our purpose here, we're going to say that the climber's coming kind of straight at the anchor. So we're going to pull in that direction. Next, we're ready to tie our master point. And when we go to tie the master point, we have a few different knots that we can use. And how you choose the knot that you're going to use is going to depend on a few factors. So we can tie this with an overhand. We could tie the master point using a figure 8 or a figure 9. And to make that decision, we're going to look at a few things. We're going to look at how much material we have in our cordelette after our 3 pieces have been clipped that we have available to us to tie that knot. So the less material we have here, then we're going to need to use a knot with fewer wraps. And the more material we have here, then we're going to want to utilize a knot with more wraps, such as a figure 8 or a figure 9. We also want to consider the height of our master point. We don't want our master point to be too low, down at our waist or below. It's going to be a little unwieldy when it's loaded to belay from. We also don't want it to be too high and it's out of reach, so we do want it to be kind of in our range of our torso if we're standing next to the anchor. And we also want to consider the angles that we're generating between the legs of the anchor. You always want to keep your angles less than 60 degrees when possible, because if you go beyond that 60 degrees, instead of dividing that force from your master point, you can actually be multiplying the forces against your pieces, and we want to avoid that. So based on the spread of the pieces and the amount of material that I have in my cordelette, I'm going to tie this particular anchor with an overhand knot. So I'm going to choke up here on the cordelette while maintaining tension. Again, I want all of these legs to remain tight through this whole process. And I'm going to take those legs, I'm going to wrap this around. We're going to form our master point. So this loop here below the knot is what's considered our master point. And these strands here is what's referred to as a shelf. And this is also another point that can be clipped into on the anchor. Now, another thing to note is when you're choosing that knot, the more wraps that knot has, the easier that knot is going to be to untie at the end of the day. After this has been loaded and this knot has cinched down nice and tight, a figure 9 is going to be much easier to untie than an overhand. So in this case, since we are using an overhand, there is a trick that we can use to help us make this a little easier to untie at the end of the day. So I'm just going to loosen up my knot here a little bit. And what we can do is we can take a spare carabiner and we can clip that into our knot. So our overhand knot is capturing the spine of this carabiner. And all that's going to do is once this knot is loaded and has been cinched down from a day of climbing, it's going to give us a little handle. We're going to be able to work on this to kind of loosen that knot. Kind of works like a spacer in the knot. It's just going to make things a little bit easier for us at the end of the day when we're tired. An important thing to note is that this carabiner that we're using as a spacer, this is what we refer to as a dead carabiner. So at no point during climbing are we going to be attaching ourselves or clipping anybody into this carabiner. It's serving one purpose, and that's just to be a spacer in our knot. So here we have constructed a pre-equalized 3-piece anchor built on 3 pieces of protection. And if I was using this anchor for a top rope setup, then I would finish by adding 2 locking carabiners to my master point. And we're going to clip these in here opposite and opposed. So I mean, the gates are facing in opposite directions. And this is where we would clip our climbing rope for our top rope. Okay, so now that we have our anchor built, we're going to review an acronym that we can use to judge and gauge the quality of any anchor type that we are going to climb on. This works for all anchors, not just three-piece anchors, but it's an acronym that spells earnest. And that's ERNEST. E stands for equalized. So we talked about this a little bit earlier. What we want to make sure is that our anchor is equalized. When our anchor is loaded, each leg of the anchor is taking some force or is dividing that total force at our master point to be equalized. That way, no one piece is required to take the full force that we might generate onto our anchor. Now again, this is what we refer to as a pre-equalized anchor, which means that we chose the direction of pull that our anchor would be equalized in. If this direction changes, this particular anchor, a three-piece anchor such as this, is no longer going to be equalized. So we anticipated the climber coming from this direction, but if our climber wanders off route or we misjudge that, our anchor may get pulled into a different direction. And in this scenario, we now see that 100% of the force is being held just by this one piece. Our other two legs have gone slack. An anchor that looks like this, in this scenario, this is not equalized. So we want to be mindful of that. And for this anchor, choosing that direction of pull is going to be very important to achieving an equalized anchor. So with what we've built here, if we're being loaded in the direction that we anticipated and we built the anchor, all three legs are under tension, and this would qualify as an equalized anchor. R stands for redundant, and what we mean by redundant is that our anchor, the total function of our anchor to hold us onto the wall, is not reliant on any one piece. So any piece of our anchor could fail, and the anchor itself will still maintain. So what we're going to do for that is we have our three legs under tension. We're going to imagine this leg gets cut either by rockfall or this piece maybe pops out. The rock fails around it, something happens. So if we're under tension here and we lose one leg of our anchor, do we still have an anchor that can hold us? Is the climber falling? Is the master point dropping? So in this scenario, because we built this anchor with three pieces of gear, we have a redundant anchor. And that's why for placing protection and building an anchor off of that, we like to do a minimum of three pieces. That way, if any one of these pieces fails, we still have two pieces remaining to hold our anchor. So 3-piece anchor, 3 solid pieces, this anchor is redundant. Next is NE, and this stands for no extension. When we're talking about extension on an anchor, we're talking about what happens to the master point if one of those pieces were to fail. And this also ties in with the equalization of the anchor. So again, we have it loaded in the direction of travel. All 3 pieces are under tension. And if one of those pieces were to fail, what happens to our master point? Does the master point move? Does it drop and shock load the remaining pieces of the anchor, which would create a spike in force and can cause the remaining pieces to fail? Or does our anchor stay in place and does not extend? So this is under tension. One arm breaks, our master point did not move. And again, that's because we equalized this so that all the pieces are under tension. So when loaded in the correct direction, this anchor would offer no extension. Now to look at that again, if our anchor was to be pulled in the wrong direction, or we have slack on 2 of those arms, if one of those pieces were to fail, or specifically the piece that is weighted, then our anchor is going to move. Our master point is going to shift. And that shifting is going to send a spike to that piece, and that could cause failure. So no extension ties in with equalization, and that's why that's such an important key. But with the anchor that we've built here, if it's loaded in the correct direction, offers no extension. Next, we're going to look at S. That stands for strong. So your climbing anchor needs to be strong. it needs to be able to handle the worst case scenario of force that could be applied to it in the situation that you're climbing. So whatever potential falls that could be generated, the weight of the climbers, it needs to be strong enough to handle all of that. The total strength of the anchor is accumulation of all the other parts, everything that we've built. So it starts with the rock that we put our gear into, that we check that rock, it's solid, it's quality, it's not going to crumble, it's not hollow. Then the quality of the gear that we've placed. So the cams or nuts that I used for my gear placement, the carabiners, the cordelette, the carabiners in my master point, all of these items are in good condition and are strong enough to handle those forces. Our anchor could pass all the other letters of this acronym. It could be equalized, it could be redundant, it could offer no extension, but if it's not strong, none of that will matter. Our anchor could still fail, resulting in injury or death. So a strong anchor is kind of core to what we're trying to achieve here. And then lastly, T. T stands for timely. So when we're in the outdoors, pursuing whatever adventures that we're going for, we are coming into hazards. So we have objective hazards that we have no control over, and we have subjective hazards, which are things that we do have control over. What we want to do is minimize our exposure to those hazards as best we can. And objective hazards we can't avoid. So if we're standing on the top of a cliff, there's an objective hazard that we could fall off that cliff and get injured. What we can do is we can minimize our time that's exposed to those hazards to increase our safety. So the ability to tie and create a quality anchor in a timely manner is going to minimize the time that you spend without a redundant, strong attachment point at the top of the cliff. So again, this comes back to what I mentioned earlier. You can practice these skills on the ground in your house. I'm here using a door frame and some quick draws to build these anchors. I can practice this 100 times at home before I go out to the rock. So that way when I get there, I'm not trying to do gear placements, figure out how to equalize the anchor, choosing the knot, figuring out the direction of pull for the first time. I have some experience so that I can do this quicker and minimize my time exposed to those hazards. It's also efficient. We become more efficient with how we use that time and energy. And it's also done in a way where the anchor is built in a clean manner. There's not sloppy knots. We can practice our knots to make sure that they are clean and can be inspected both by ourselves and other people in our climbing party. So with practice, this anchor can become timely. And so equalized, redundant, no extension, strong, and timely. This is a quality anchor that we can climb on.